Hey, good morning, class. So this one is another video. So this one is for section 6.4, part 2. It's about the ambiguous cases. So when can we apply the law of sine? Last time we talked about the way to apply the law of sine is by if the triangle is considered angle psi angle or angle psi. So now what happens once you deal with the triangle that's considered psi angle? So now we need to go through the ambiguous case test. So anytime that I deal with the triangle that's given as a psi angle, so we need to go through the process of the ambiguous cases. So let's say angle A, it's a cube, and A, it's less than the other side. So let's say we do have two sides given, psi angle. So A is the shortest leg, it's less than the other given side. And also, if A is less than C sine A, so C sine A, which is the height of the triangle, so if you see anything like that happen, so that means there's no triangle form because that the other side is kind of short, okay? It's not going to be a triangle. And then if you see anything that's considered A equals C sine A, so that it's going to be a right triangle, so that means there's only one triangle exists. But the thing is that if you see anything that's considered A, it's greater than C sine A, so the shortest leg, it's greater than the height. So that means we do have two triangles. So that means we need to find out two different sets of solutions. Okay, so we'll take a look at that. And for those you might be wondering about the proof for this, so this one, if you just look it up for like certain kind of video on YouTube, there's like some kind of proof. But I don't want to go to like a crazy proof for this one. Okay, so I just want to go through like the basic stuff that you need to know. Okay, so now the first example. So let's say we do have angle A, 78 degree, A equals 21.2, C is 24.7. So this one is given as an angle, psi angle. So let's just draw the diagram first. So the way to read through that is from either by clockwise or counterclockwise to read through the triangle. So it's given as psi angle. And you may notice that A, it's the shortest leg. And obviously this one, A, it's less than C. Okay, so the shortest leg, so A, it's less than C. So one thing that we need to find out is the height of this triangle here. So let's say that you want to make a perpendicular segment from vertex B to segment AC. So you see that's a perpendicular segment. And then, so that would be the height of the triangle. So let's find out the height right here. So A versus C sine A. So just by plugging a number, so C sine A is 24.7 times sine of 78. And that would give you 24.16. So obviously A, it's less than C sine A. So this one is going back to the ambiguous cases. So this one, it's condition number 1. So if the shortest leg is less than the height of the triangle, so that means the triangle does not exist. So there's no triangle form. So that means no solution. Okay, so now here's another one. So let's say we do have angle A, 49 degree. So the shortest leg, A, it's 21.5, and segment B, it's 23.9. So once again, just by plugging a number and then just set up the triangle here. So we do have A, B, and C. So triangle ABC. So once again, so this one, we just want to compare that, the shortest leg with the other side. So the shortest leg is less than the other side. So now let's find the height. So it's A versus the height, or B sine A. Again, if you just swing the segment here all the way down perpendicular through segment AB, so you see that's going to be the height right here. So the way to find height, it's B sine A for this case. So B sine A, we do have 23.9 times sine of 49, so which is 18.04. So the shortest leg, it's actually greater than the height. So if that's the case, so that means we do have two solution sets. So we're going to have two different triangles formed. So one would be acute, like this one. The other one is going to be obtuse. So we'll talk about that later on for this video today. So here's another one. So we do have angle B, segment A, segment B. So once again, it's psi angle. So once again, draw the triangle. So with the label. So segment B, which is considered the shortest leg, so it's the shortest leg versus the other given size. So we do have 16.5, so 9.5 obviously is less than 16.5. And now once again, whatever the shortest leg that we have, we want to use that to compare it to the height. So the way to find the height, right here would be A sine capital B. Okay. So 9.5 versus 16.5 times sine of 35. So let's find out what that is for that height. So it's 9.5. So this one's exact same value. So if that's the exact same value, so that means there's only one right triangle. So there's only one solution. Okay. So now let's do some random problem. Okay, let's just skip through all this. So let's go through the one that I would like to talk about here with that side-side angle. So those are the example which you'll see that from the textbook. Okay, so those are the homework problem. So now here's the one. So if you try to run through the ambiguous case test right here, so let's say we do have angle A, 32 degrees, A is 7, and B is 10. So if you try to do the ambiguous case test, you'll see that the height is actually less than segment A. So A is the shortest leg of this triangle. So anytime that you deal with this, so that means two triangles are being formed. So one is acute, the other one is obtuse. And let me show you the reason why this one is true. Acute and obtuse. Again, angle A, we don't change that. It's the exact same angle, which is given. So segment A, so that's 7. So here's 7. And then segment B, we do have 10. And also here, we do have 10. So now, and how do you find out the rest of the unknown? How do you find out the rest of the angles and also the third line segment? Okay, so let's take a look at that. So let's start out with the acute triangle. So by using the law of sine, so we can find that it's 49.2. Again, the law of sine would be given as sine of 32 over 7, and then sine of angle B over 10. So once you cross multiply and try to isolate that sine of capital B, and then you take the inverse, so we get 49.2. And then what about for the obtuse angle? In order to find out the measure of angle B, the second solution for that obtuse angle, so we're going to use the reference angle. Okay, so take a look at that. So 49.2 degree, so that's in quadrant 1. But now think about this way. So if that's obtuse, so that means the angle is going to be in quadrant 2. Because that obtuse angle, by definition, obtuse angle is always greater than 90 degrees, but it's less than 180. So if that's obtuse angle, 49.2, that would be standing as a reference angle. So in order to find out the obtuse angle, so we subtract 49.2 from 180. So we get 130.8. So for that second solution of angle B right here, so it's 130.8 degrees. Okay, so another way that I can explain it is because that they're supplementary. Supplementary angle, so that means the sum of two angles is always 180. And now let's find out angle C. So in order to find out angle C, you want to use the triangle sum theorem. 180 minus 32 minus 49.2. And this one too. So 180 minus 32 minus 130.8, you'll get 17.2. And then the last thing that you want to do is solve for C, segment AB. So again, using the law of sine, so you get sine of capital A, so which is sine of 32 over 7. So that equals sine of capital C over little c. And then use the law of sine, you get 31.1. And then for the obtuse triangle, same thing. Use the law of sine, you get 3.9. Now, another thing you probably want to check right here. So whatever the shortest leg that you have, it's always corresponding to the smallest angle of a triangle. And back to geometry, this one is called the Hinge Theorem. If you guys do remember that. The shortest leg, it's always corresponding to the smallest angle. In other words, so the smallest angle is corresponding to the shortest leg. So check that, the shortest leg right here, so 7, so it's corresponding to the smallest angle. And then 10, the medium segment, so it's corresponding to the medium angle. And then the largest angle, angle C, 98.8, it's corresponding to the longest leg, 13.1. And then same thing happened right here, so C is the shortest leg here, so it's corresponding to the smallest angle. And then the longest leg, 10, is corresponding to the biggest angle. The medium segment is corresponding to the medium angle. Okay, so it's all about the Hinge theorem. If you find out something that doesn't corresponding to each other, so that means, you know, there's something wrong with the triangle, or maybe something wrong with the solution that you find. Okay, so now let's look at that another one. So let's say we do have angle A, 29 degrees. So segment A, 15, segment B is 19. So draw the triangle. So we do have two triangles. So one is obtuse, the right hand side right here, and the other one is acute. Again, we don't change the value for angle A because this one is the constant. It's given already. So segment A, it's also given. Segment B, it's also given. So again, so using the law of sine, well, the first thing that you want to go through, obviously, is the ambiguous case test. So we'll find out that A is actually greater than the height. So that's why it's two triangles. And then you try to solve for this. So use the law of sine. So we solve for angle B first. So we got 37.9, excuse me. And then using the supplementary angle condition, we can get the second solution. So 180 minus 37.9, you'll get 142.1. And then use the law of sine again. So we got, well, use the triangle sum theorem, excuse me. So you got 113.1, and then the other one, 8.9. And then use the law of sine once again. So you get 28.5, and then 4.8. Okay? So thank you for watching the video today. So any questions, any concerns, so please put it up on Google Classroom or the YouTube channel. So I'll see you guys next time. Take care.